All right, so Intermediate Algebra 1033C Test 2 review session. So we got 20 questions to hit up. These will look just like what you're going to see on your test. The only difference is we're going to change the numbers. Okay? So let's get started. Question 1. Determine the ordered pair is a solution to the given system. Write the correct letter in the space provided. And yeah, so you got two of these where they give you the points and they want to know, is it a solution? How do we check that? You can actually solve it, absolutely, but there's an even easier way. Plug them in. You want to check and see if there's a solution, just plug them in. And remember, to be a solution, it has to work in both equations. It has to be true in both. So let's plug in. So this is your x, this is your y. Okay? So we'll go up to the first one and we'll plug it in. The moment it doesn't work, you stop. You don't have to do anything else because it will not be considered a solution then. Equal to 72. So again, this -3 is where the x used to be. This +3 is where the y used to be. So let's see here. This right here gives us -12 because 4 times -3 is -12. Over here, this 20 times 3 gives us 60 equal to 72. Sorry, go ahead. Oh, I have them in different orders. Yes, absolutely. That's me not paying attention. Thank you for catching it. Yeah, it definitely helps when you put them in the right spot. So the y was actually by the 4, so that's a +3. The negative is right over here, so yes, that would be a +60, and that'd be a +12 there. And does that work then? Yes. So far, it works in the first one. So now all we got to do is just check the second one then. So we're going to take the -4. We'll put in the +3 for that one because that is the y value. -8 times the -3 equal to 12. I believe I've got everybody in the right position this time. So this time we've got -4 and 3, so that's a -12. And then over here it's like a -8 and a -3, which makes a +24. And does that give us a +12? Yes. So it works in both. So is this a solution? Yes. So yes, the ordered pair is a solution. And then we're going to check the next guy. So 5, -5. And we're going to repeat that process again. So let me change up my color. The +5 is x, the -5 is your y. So plugging in, making sure that I plug in correctly again. 4 times your y value, which is -5, minus 20 times your x value, which is a +5, equal to 72. So 4 and a -5 give us that. Absolutely. Careful. That would be a -100 equals 72. No, that doesn't work. So -120 is not the same thing as 72. So we come up here. No, that one is not a solution to the problem. It is not an ordered pair solution. Cool? Yes. Any questions so far? Good. Hopefully I'll make all this a little bit easier for you. So this guy right here, they want you to graph the system. Graph the system. All right, hopefully I can help you out on this one. The cool thing is both of these are in what form? Slope-intercept form. So the way I taught my students is I called this Google Maps, because it's going to be like Google Maps is going to find you, and then it's going to tell you directions to wherever you're going. And how did we do that? What is it that we got to do first when we have slope-intercept? And that's all right. You're going to plot B. What does B tell us? Careful, B does not tell us it's 4 and 3. It's one of those two numbers up here. It is the 4. No worries. Oh, I get what you're saying, the 3. You're looking at the purple one. I'm keeping the blue with the blue, so we're focusing on the blue equation. Yeah. So B is 4, but what is that? Who does that represent? That's the y-intercept. This is, like I said, this is Google Maps finding you, and it's finding you on this y-axis. Okay? And it found you right here. That's Google Maps finding you. And then now I do what we call use M, or use the slope, because slope is directions. Slopes are your directions. What is the M in my blue equation? -3. But it needs a bottom number, so what is that over? 1. Yeah, whenever you do not see a denominator, it is automatically 1. So what does that top value tell us to do? So it is the rise, which is up and down. Whoa, come back. So what does a -3 tell us to do? Where are we going? We're going to go down 3. Over which direction 1? To the positive, to the right 1. So from where Google found you, do those directions. Go down 3, to the right 1. 1, 2, 3, right 1. And you could just continue that pattern all you want throughout the entire picture. 1, 2, 3, right 1. These are just some other points that we can plot that help me make my line a little bit straighter. So now we can graph. Remember in iMath you'll have those little tools that are down below that are like, it'll have the line in one of them with 2 dots. It'll have the circle, I think, with 2 dots. Quadratic. I think it has the absolute value and then has the dot at the end. So when you're doing this, you're going to be using this first box right there. And remember, it takes 2 clicks to make the line. So your first click should be the y-intercept, and then your second click should be after you've used the M, and then it solidifies the line for you. So you don't have to keep going like what I did. I just did it so I can draw a little bit straighter of a line. Correct. You would have went up 3 and then to the right 1 if the top number was a positive. So let's talk about the next one. And I'm just going to do this in purple. Okay? So, again, what are we going to start with? B. Plot B. So where is B at? What is our number? 3. And that's the one that you gave me earlier, which I was like, I thought you were still in the blue equation. I was like, no 3. So on the y-axis, we're up at what number again? 3. Okay. So right here, it's found us. There's Google Maps has found us. And then what are we going to do next? So we want to use M. And what's that top number tell us to do? That's right. Over which direction? Whoops. Go back down, you silly board. So to the right, 1. So from that purple dot, we're going to go down 1, or down 2, right 1. Down 2, right 1. Down 2, right one. This is just to help me kind of solidify my line a little bit. And there we go. Okay, again, remember this is just a 2-click idea. Once you are working with your line, your first click will be on the y-intercept, and then you should go down 1 or down 2 to the right 1, and your second click will solidify the line in the program. And last but not least, it wants to know in the space provided, I don't know if these got the space provided down here. Nope, doesn't look like it. So in the space provided, write the point of intersection. Where is it up here that these two lines hit? 1 and 1, right here. Absolutely. So down below, hopefully they have a parenthesis with two little boxes, and all you're going to do is put 1, 1, and that's the answer. How's that graphing now? A little bit better? Just got to remember it's like Google Maps. You got to get pinpointed, and then you got to use those directions. Everyone good on that one? Okay. Question 3. All right, so down here, you're basically going to look at the picture and tell me how many solutions it has. Okay? So if we look at A, there's only one line. So what does that mean for the system? Not that one. Nope. You just saw one solution. This is a one solution. They actually intersected and they hit each other at one point. It's many solutions. The reason why you only see one line is because both of your equations were graphed on top of each other. They're the same line. So if I had a colored graphing calculator, it would have done this. It would have said red line, and then you would have saw the blue line go right on top of that. And that is a infinite solution because both of them are the same. What works in one has to work in the other. What is B, though? What kind of lines are those? Two solutions? Do they hit each other? A solution means that they're going to hit somehow. Yeah. So what kind of lines are these in part B? That's a no solution because what kind of lines are they? They're parallel. That's right. Parallel lines will never hit. So that right there is a no solution. When you have two lines that never hit, that is a no solution for us. And then the last one, C. 2. How many times does it hit? 1. Yeah, that 2 solution option is junk in this. The systems we work with only either have one solution, no solution, or infinite solutions. So if you see something that says 2 solutions, you can go through and mark that bad boy out because that ain't going to happen for us. It's above our pay grade right now. Yes. Well, not chemistry, but college math, college algebra. Yeah. You'll see something like that in college algebra. Guaranteed. Yep. When we start talking about quadratics and circles and things like that. Yeah. That's for later. Any questions about this one? That's all you got to do. Tell us how many solutions it has. And again, you can see that this one is 1 because it only hits it one place. There's only one dot. There's only one intersection. All right, question 4. So up here, again, this says elimination. You have learned 3 methods, and I've told my students this, and hopefully maybe your professor kind of emphasized this to you. Even though the directions say do elimination, this test is on computer. Do I really know if you did elimination? No. You can graph, you can do substitution on this, you can do elimination. Do not get me wrong, elimination is probably the easiest method for this. That's why it's in the directions. Oh, well then in that case, since yours was paper pencil, yeah, you probably should do elimination. Okay? But you know 3 methods. So generally, it becomes dealer's choice, because part of being a math student is learning when to do something on your own, which method to use in different situations. All right, but let's go ahead and do elimination on this, because it is going to be the easier method. So in my courses, I have my students look at their variables, and I have them look for 2 things. Look for the same number in front, one of them being positive and one of them being negative. So they got to have those 2 things. They got to be the same number, and one of them has to be positive, one of them has to be negative. Because when I add the same number, one positive, one negative, it becomes 0. It eliminates. So if you look up here, if you look at x's, are these 2 the same number? No, but we do have a positive and a negative. That's good. All right, so look at your y's. Are these 2 the same number? What number is in front of that y that's right there? A 1. So if you need to write that in, go ahead and write it in. So they're definitely not the same number, but do I got one positive, one negative? Absolutely. So, sorry, go ahead. Ah. Will it? Okay. Okay. Yeah. You're kind of jumping the gun on me, but yes, we're going to go there. Yeah. No, it's all right. So obviously I don't have the same number in front. And I like what you were doing. You said let's multiply the top one by 5, because who were you originally trying to get rid of? One of those, x or y. But you chose 5 because in your mind you are really getting rid of the y. Ah, well, okay, there we go. We can do that too. Yeah, they will. So when this is what I call the goal of elimination. When that you don't have the same number and one of them is positive, one of them is negative, things like that. When the goal is not met, we have to multiply one of these equations or both of them. So you said you wanted to get rid of the x, right? So I make my students write down the x, because that's the variable they chose. Okay? And then now you've got a 30 and a 6. What number can I make both of them? No, not what I want to multiply. 30. Yeah. Okay, let's get rid of the y. All right, we'll do that. But it's okay. Let's just continue with this. So we'll make them both 30. And which one did you want to be the negative? The top one or the bottom one? Yeah, because it's already negative, right? So you want this to happen. Okay? And you did this real quick. Most of the time, these decisions are made in our mind really, really quick. Notice this guy and this guy already match. So do I have to change the bottom equation? No. So we're going to leave it alone. If it already matches, leave it alone. Okay? But you said earlier, we need to multiply this by what again? 5. Because 5 times a negative 6 gives us the negative 30x. So we only have to multiply one equation. Sometimes you only multiply one. Sometimes you multiply both of them, depending on what you want to eliminate, like the x's, and what number you put in front. So let's continue on. What is 5 times the 1? 5. So a positive 5y equals, and then don't forget that you have to multiply all the way through. Go all the way through. You should be multiplying 3 times. Multiply the x, multiply the y, and then I call this the equal part. Multiply the equal part. 5 times 2, 10. And now we're ready for elimination. What do we do next? Elimination. Yeah. These guys are going to cancel by adding down. When you add down, negative 30 plus 30 is 0. When I add down, positive 5 and negative 5 is 0, right? So if everything cancels over here, what number is left? 0. And that's important to us. We have 0 there. All right, so what's going to happen over here? Negative 15. Now you have 0 equal negative 15. Does that make sense? No, that just don't make any sense, right? Just don't make sense. That's like saying if I have no money and Yolanda's in debt $15, I'm better off. I got no money. I'm okay. But she's got some bookie coming after her wanting that $15. Okay? I'm in a better position. But since this doesn't make sense, what does that mean solution-wise? There's no solution. Yep. So in this little point, you would put DNE, DNE. Because there is no solution. When you have two numbers equal to each other and they're different, like in this case, number equal to a number, and we are different, that's a no solution. What happens if you have a number equal to a number and they were the same? That's an infinite solution. Yeah, infinity, all the same. Yeah, you'd put OO, comma OO, or wherever the infinity sign is. Okay? Yeah. Any questions on number 4? Cool, moving on. I believe the next one should be all about substitution. And the reason why we call this, we want substitution on this one, because it's ready to go for substitution. Because in class, when I talk about substitution, I say look for the variable that is solved. In other words, I want something that says y equals or x equals. And who do we have? We know what x is. Right here. And what are we going to do with this x information? That's right. Substitute it into the other one. Replace the x in the other one. Plug it into the other equation. Shove that equation into the other equation for x. However you can remember it, but you're substituting in. So yeah, I always use substitution whenever I have a variable that's automatically solved. So we're going to plug in. We got -4 parenthesis. Oh, this is x, so we're going to put 5y minus 1 plus 20y equal to 4. Any questions so far about what happened? All we did was plug in, and now we're going to solve for what's left. We're going to figure out what the y variable is. So what is -4 times 5? -20. So -20y. What's -4 times -1? +4 plus 20y equal to 4. And now put your like terms together. Who's going to get together? Yeah, the -20 and the +20. What's going to happen to that? Cancels. So what am I left with? 4 equals 4. What is this? Yes, that is correct so far, but what's the answer? What would I put into my point because my variables are gone? Infinite because they are the same number. Remember, we just talked about this. So how I'd write that up, I'd put my little infinity symbol here and my infinity symbol there. Okay? Substitution is plugging in, replacing. And the cool thing is, on this test, it should be ready to go. It should have a variable solved. All you got to do is slap it in. I can't guarantee the quiz. This is all about your test review. Any questions so far? Everyone good? Yeah. The test will look just like this. No jokes. All right. This one, they didn't throw this in the homework, and that irks me some, and I've already talked to them about this. But they want you to use elimination on this. So we're back to elimination. They've chosen your method. But what do you notice is in this? Fractions. I know, like your favorite friend, right? Never. You will never stop dealing with fractions. But again, that's why you have your graphing calculator, because you have your best friend, the fraction key in it. If they haven't shown you where that's at, I'll show you where it's at. Okay, but before we get to the fraction key anyway, I know you hate fractions, right? So what they want you to do in this one is they want you to clear out all the fractions beforehand. What clearing the fraction means is they want you to multiply by a common denominator. They want you to multiply everybody by a common denominator. Okay? So look at your denominators for this first equation. What are they? It would be 10. Yeah, 5 and 2. And what number can I make both of them? 10. So yeah, everybody up here is going to get multiplied by 10. You get a 10, and you get a 10, and you get a 10. Everyone up there is going to get multiplied by 10. This is what we call clearing the fraction. When you multiply everybody by the common denominator, you're clearing the fraction. You're going to see that again in your module 3. Clear the fraction. So again, the goal of clearing the fraction gets rid of the fraction, right? Nope, we're going to get rid of them. Because I know how much you guys hate fractions. So the 5 is going to cancel. And what was 10 divided by 5? So the 10 now becomes a 2. Because the 10 helped cancel out the 5. You follow me on that? So the 10 canceled out the 5, but not all the 10 went away. It was left with 2. So what do I have left for my x? Well, what's 2 times 2x? You got it. 4x. And then the y gets multiplied by a 10. So what does that give us? Plus 10y equals. And then again, the 10 is going to help us cancel out the 2. But the whole 10 didn't get canceled out. So what was 10 divided by 2? So there's 5 left. So it's 5 times negative 1. Negative 5. That's a little bit easier to work with than the fractions. And that's called clear the fraction. And we're going to do it again at the bottom. At the bottom, what would I multiply everybody by? Yeah, your only denominator is just the 6. So everyone's going to get multiplied by 6. So you get a 6, and you get a 6, and you get a 6. So there's no canceling on the x, so it's 6 times x. Yepers. Remember, the 6 will take out the 6, and since they're both the same, they actually take each other out. There's nothing left. So what do I have left right here with the y? Negative 5y, yeah, absolutely. Equals, and then 6 times negative 2. Yeah, negative 12. And now we're ready to begin elimination. Now we're ready to begin elimination. And these two equations are much easier to work with than those nasty little silly fractions. That's what we call clearing the fraction. Multiply everybody by that common denominator and it gets rid of it. So now we can go back to what we talked about earlier. Let's pick a variable, and it doesn't matter which variable. And this time they will not both cancel out. Okay? You want to get rid of the y because it's easier. I like your thinking. It is the easier of the two. Because if I wanted to get rid of the 4 and the 6, I would have turned them into 12, which means I had to multiply both equations. Or you could have turned it into, whoa, go back. Or I could have turned them into 24. There's lots of different numbers. I could have made them both. But the y is easiest because what value can I make both 10 and 5? No, it can't be any smaller than 10. What value are they going to become? What's the number? 10. Absolutely. Yeah. There we go. So we're going to get rid of the y. We're going to make them both 10. Who did you want to be to the negative? The bottom, because it's already negative, right? So if we look up here, don't these two already match? So leave the top equation alone. 4x plus 10y equal to negative 12. Or sorry, equal to negative 5. What do we have to do to the bottom one to get the negative 10? times it by 2. So what's 2 times 6x? We already know that's going to be the negative 10y. What's 2 times negative 12? Okay. And what are we going to do now? Add down. So what's 4x plus 12x? Okay. Oops, too far. So 16x. We know the y's are gone. What's negative 5 negative 5 minus 24? Negative 29. Okay. Now what? Divide by 16, divide by 16. I want to check something real quick, make sure that we're still recording. Yeah, we are. All right. So x equals, oh, it doesn't reduce. How dare they? Sometimes that happens. Sometimes you're going to get that nasty looking number. Okay. So now that we know what x is, how do we get y? We got to plug in the x. I just want to double check some things, make sure that our math looks good, because that is one nasty number. So that gives us the 4x, the 10, and the negative 5. So that looks correct. 6x, negative 5y, negative 12. We had to multiply that by 2. Yep, check it out. Okie dokie. So, how do we get the y value again? I'm sorry. We got to plug it in. Where do you plug it in at? Yeah, you could take one of your original ones, or again, as I've told you in class, you can use one of the ones that we worked with and manipulated. I'm going to go ahead and plug it into the top one. All right. So we're going to plug into this guy that was up here. And I'm going to use those exact numbers. Again, I know they are. Oh, you want to use the 4x. We can plug into that one too, because we know it's written right. I mean, we all worked it together. Okay. You could plug into either one of those. Doesn't really matter. And remember, you have your fraction key on your calculator that can help you out. So we're going to take that x value, and we're going to plug it into that equation. So, my x is negative 29 over 16, and then it was plus 10y, right? Plus equals negative 5. All right. So I'm going to go to my calculator, and we're going to start working this thing out. So we need to take 4, and we need to multiply that by the negative 29 over 16. Where is our fraction key? Alpha y equals, right here. Our green button, alpha, hit your y equals, and there's our fractions. And so you just hit enter for the number 1, and now we can put in that negative 29 over 16. Again, that was alpha y equals. So negative 29 over 16. Close that parenthesis, hit enter. So we now know that first number is now negative 29 over 4. Follow me so far? Okay. Did you hit alpha y equals? Those are fractions. So when you hit enter, you can put that negative 29 over 16. Okay, so jumping back, we now know that it was negative 29 over 6, right? Or 4. Nope, 4. Ooh, almost had the wrong number. Plus 10y equal to negative 5. Now what are we going to do? Now what do we got to do? How do we get y by itself? Yep, add 29 over 4 on both sides. And again, I ain't going to work this by hand. I'm going to let that calculator do my hard work for me. I'm going to go to my calculator. I'm going to push negative 5 plus 29 over 4. So my calculator, -5 plus alpha, y equals, put in the 29 over 4. Hit enter. There's my new number, 9 over 4. I like it that it keeps getting smaller and smaller and smaller. You doing all right? No? Where did I lose you at? Okay, sure. So we just went into the calculator and I typed 4. I put a parenthesis. And then you didn't get the negative 29 over 4? Okay. So you know where that's coming from, right? And then now, come on you, I got to get the y by itself. So how do I get rid of a negative 29 over 4? I add it to both sides. So all I did was go to my calculator and take -5 plus the 29 over 4. And that's what gave us, the 10y equal to 9 over 4. Because -5 plus the 29 over 4 gives us the 9 over 4. Okay? Because you can see it right here in our calculator. -5 plus 29 over 4, 9 over 4. And then what now? What are we going to do now? Divide by 10 on each side. Divide by 10, divide by 10. Again, I'll just go to my calculator. That's not supposed to be a G, that's supposed to be a Y. Just go to my calculator, and all I want to do is take that last answer and divide it by 10. So just hit divide by 10. This A and S means that's the last answer that we just looked at. So this A and S right there represents 9 over 4. And all we want to do is just divide it by 10. Hit enter. And there's our final answer for the y value. Nasty little number, 9 over 40. 9 over 40. So now the point is complete. That's what they want in the blanks. They do not want decimals. They want that exact value. Any questions so far? I know fractions are the worst, but just let that calculator help you out. Okay. All right, let's jump to the next guy. Let's jump to the next problem. So now, your favorite. We're going to start throwing word problems at you. Okay. We're going to start throwing word problems at you. So, and here, for the next ones, you're going to basically use any method you want. You can graph these, you can do substitution, you can do elimination. This one, even better. If we read the directions, it says, do not solve the system. All they want you to do is set it up. And the cool thing is they tell you exactly what to do up here. They want you to translate. Now, some other things to notice in this when you read through, it's also telling you what variables to use. So don't use your own variables. They want x to represent the first number. They want the y to represent the second number. So keep that in mind when you make your equations. Because I know when I teach this section, I tell my students to let the variables represent the numbers. So I would usually use F for first and S for second. But they tell us what variables to use. So up here it says translate. That means that they are giving you operations as words. We need to put it back into symbols. So here's our first sentence. What does the sum of two numbers is 12 look like mathematically? Six plus 6, but we don't want numbers. We want to have variables in it. X plus y equals 12. Because sum means to add, right? So we're adding two numbers. Do we know what those two numbers are? No, that's the x and the y that we have down here. Your equations have to have those variables in it. So sum of two numbers is just x plus y. Remember, is in here, I told you in class, is just a fancy way of saying equals. So equals 12. There's your first equation. That is your first equation. The second sentence up here is the second equation. So it says the first number is 2 less than 5 times the second number. So let's start translating. Who's the first number? Who's the first number? Yes. So this is saying x is, what is? Equals, absolutely. So x equals, now the question is, what is 2 less than 5 times the second number? So you have some operations here. That less than does not mean like the less than symbol. It's an operation. What operation is less than? Subtraction. And then you got another operation word right there, which is times. Times is multiplication. So I need something over here with subtraction and multiplication. There has to be the variable y. And then you got a number 5 and you got a number 2. So what does that look like over here? 2 less than 5 times the second number. Yes, and I love that you put the 5y first. That means someone has told you about this silly little word right there. When you have the less than word, normally when we translate, we always translate left to right and we take it in the order that it's given. But the less than right here means that everything is in reverse. Okay? It means that what comes after the word less than is really the beginning. And what comes after the word less than is really the beginning. So that's the 5y. What comes before the word less than is really at the end. That's why it's minus 2, because the 2 became before the word less than. It's written in reverse. It's backwards. And that's it. That's all they wanted you to do on this. They wanted you to write the two equations. Done. Any questions on number 7? You are translating the sentences back into their symbols. It's like if you're having a phone conversation with a friend and this is what they said on the phone, what would you write down on your piece of paper? That's kind of the idea behind translation. Okay. Let's talk about number 8. All right, so number 8. Again, use any method now, and they want you to solve this, okay? And it is a system of equations. Again, this is a lot like what you just did a moment ago. Do you see words that represent operations? Sum, is, times, and there's one more. More than. What operation is more than? Plus, yes. It's not the greater than symbol. It is the addition symbol. Okay? So, let's take each one of these, and just like last time, let's translate. Because that's all this is. It's just another translation, although we put a little bit of context behind it. We're talking about angles. Okay, no biggie. So, it says the sum of two angles is 160 degrees. So, what does that look like? No, the equation. This is all about equations. The sum of two angles is 160 degrees. Equals, boom, there it is. Because I want to see what you're going to do with it. Yeah, the angles doesn't really mean jack squat. It's just like I said, this is just like the last one, except They've given you the context of angles. We're on number 8. So there's your first sentence. Well, we'll get to that. We'll get to that. That's for the answers. We'll fill that in just a moment. All right, so now we're on the second sentence. So it says, one of the angles is 22 more than 5 times the other. So again, just start at the beginning. It says one of the angles is. What does that look like? X is, or X equals, yes. X equals. What does 22 more than 5 times the other look like? You're so good. 5y plus 22. There you go. Yeah, more than, it's just like the less than. Things are written in reverse. But since it's addition, I'm a little bit more forgiving. And if you wrote 22 plus 5y, that's still okay. Because 2 plus 3 is the same thing as 3 plus 2. It's the same answer. You can add in any order you want. It's subtraction that you have to be careful of. That's why I said over here, this little less than guy, it's all written in reverse. But you see, these two problems were the exact same. All I did, instead of just calling them a number this time, I called them an angle. It's the only difference. But this time, they don't just want the equations, they actually want us to solve. So what method will we use to solve this? Plug it in, which is called which method? Substitution, yeah. Let's take what we know for x and where we're going to plug it in at? Yeah, the top one, 4x, right? Let's plug it in, plug it in. So we got 5y plus 22, because that's what x is, plus y equal to 160. Follow me so far? This guy that was right here, this 5y plus 22, that used to be x, but we replaced it. We substituted it in. We plugged it in. Okay? All right, so what do we do now with all this information? What are we going to do from here? How do we solve the rest of this? Yeah, combine like terms. Who's getting together again? The y's. So what is 5y plus y? 6y. Good, because there's that 1 there, right? 5 plus 1 is 6. And then we got plus 20 dose equal to 160. Now what are we going to do? You got it. Continue to get that y by itself. Subtract 22. Minus 22, minus 22. 6y equals, what is 160 minus 22? You got calculators. It's okay to use them. You don't have to use that. I mean, hopefully you could use some of that brain power to figure it out, but that's all right if you don't. 138, okay. And now what do we do? Divide by 6, divide by 6, divide by 6. Hopefully this comes out nice and neat, and yes, it does. How much? 23. So one of our angles is 23 degrees. Is that the smaller one? Is that the larger one? I don't know until we find the other guy. So how do I take this 23 and find the other one? Yeah. We're going to substitute in. We're going to plug either into the top equation or into the bottom equation. It doesn't matter. Do the top one again. I would have went into the bottom one because it's already going to tell me what x is once I plug it in. But that's okay. Let's go into the top one because that's what you said. No. I like to do what you guys do. I know you do. So x plus 23 equals 160. So what do we do to solve? And there's nothing wrong with doing the top one because it's just as quick too. Oh, you act like this. What are we going to do? Yeah, you just got to subtract 23. Gosh. So what is the x value? How much? 137? Okie dokie. All right. So who is the smaller angle? The y. And what value was that? So that's what goes into that blank. And the larger angle is 137. And there you go. There you go. Yes, yes. Substitution, there's a lot, or systems in general, it's just a lot of work sometimes. Okay? How you feeling so far? Good? Right on. Right on. Moving on. Question number 9. We're almost through all of the systems. We're almost there. Okay? We got this one, and I believe one more word problem after it. All right. So, any method you want. So it says there were 586 people at a play. The admission price for adults was $19 and $7 for children. If the admission receipts were $7,210, how many adults and children attended the play? So, in my courses, how I taught this is I said that your word problems came at you in one of two ways. They came at you like translation problems, which is what we've been doing in the past 2, or they came at you as standard form problems. And when I said that they were standard form problems, because they give you totals. Do we have totals in this? What are the totals? 586. So that's going to be one of our equation ends. And then you'll have some sort of variables on the other side that affect that, like standard form. The variables are going to be on the same side. Who's another total? Yeah, 7,210. So now we need to write the equations for these. We know that they're going to be in standard form. We know that we have to have 2 variables over here that equal that total. So let's start with the purple guy, because it's going to make the most sense once I finish that one with how the second equation, the top one, the 586 will come out. Love it. Absolutely. But instead of calling this X and Y, let's use a little bit more descriptive terms. Let's call it A and C. So 19A plus 7C. So that way we know in the end, once we figure out what A is, that means that's for adults. Okay? Where X and Y, they're not as descriptive, and you could forget, what was X about? But now if I have it as A, we know that's definitely adults, and C is definitely children. So we've used the 19, we've used the 7, we've used the 2 totals. There are no more numbers left, and we do not repeat numbers. What does the top equation look like then? A plus C. When you run out of numbers, when you've used everybody, the only thing that you can have left to write is A plus C. Your 2 variables added together. I guarantee it, because we do not reuse numbers. And again, this kind of makes sense. Let's take a look at what these equations really represent. 586 is all about people, right? What was the A about? Adults, not tickets, just adults. What was the C about? Children. People, people, people. That top equation is nothing about people. Look down here. What was the 19 about? Money. What was the 7 about? Money. What was the 7,210 about? Money, money, money. People, people, people. They make sense. Okay, your equations should make sense in the end after you look at them. All right, so now all we got to do is solve. What would be an easy method to solve this one? Elimination. I would go elimination all the way on this one. Do not get me wrong, you can do substitution. You can get the A by itself and then plug in. You can get the C by itself and then plug it into the other equation. But elimination is pretty easy to do on this. So let's do elimination. What variable do you want to get rid of? Let's get rid of C. Okay. So what number can I turn them both into then? 7. Who do you want to be the negative? Yeah, the bottom one's already positive, so let's just make the top one. Any questions so far about what, who we chose? We can get rid of the A, do not get me wrong. You can get rid of the A first. It's your choice. But the easiest thing to do is get rid of one of them. And the cool thing is basically all you're going to do is either just multiply the top by a negative version of that number. So to get rid of the C, all I got to do is multiply this by the 7, negative 7. If I wanted to get rid of the A, what would I multiply the top by? A negative 19. Yeah, elimination's pretty quick. You just multiply by the opposite of whatever number is down there. So let's multiply through. What's negative 7 times A? We already know what's going to happen with the C. What's negative 7 times the 586? Again, I'm not that good, so I'll have to have you help me with the calculator. Everything's moving around. Negative 4,002. Gotcha. Negative 4,102. All right, the bottom guy. These two already match, right? So do I do anything to it? Nope. So we got 19A plus 7C equal to 7,210. What do we do now? Add down, right? So the C's are going to disappear. We got negative 7 plus 19. What do you get there? 12A, okay. Equal to, we got negative 4,102 plus 7,210. And what are we going to do now? Divide by 12 Z's. Divide by 12. And these numbers should come out to nice, neat numbers because, again, you're talking about people and children. I don't know what 0.3 of an adult would look like. Okay? It's not just a leg and a torso hopping around. Okay? So what is 3,108 divided by 12? 259. 259 what? Who are we talking about here? Adults. So at this play, there were 259 adults. How do I figure out the children? Plug it in. So go back up here to one of our two equations, either the green or the blue, and plug it in. Which one did you say? Yeah, I definitely go into the green one. Less numbers to deal with. They're all smaller too. So all I'm going to do is plug the 259 in for A and solve for C. 259 plus C equals, it should be 586. So what do we do to solve? Yepers. So C equals what? There we go. 327 children. Cool? Hopefully you're starting to see some of those patterns for these problems exist. And they're the same patterns that hopefully you saw in your homework. Okay? All right. I believe we have one more system problem. What's up? Yes, I can. I can definitely scroll back down. There you go. All good? No worries. Okay. So, number 10. I believe this should be our last one. Oh, nope. We got some inequalities, but that's all right. Those aren't that bad. So, solve the application of systems, any method again. All right, the amount of 1,324 is invested into two funds paying 6% and 11% simple interest. If the annual interest is $103.79, how much of the 1,324 is invested at each interest rate? Again, what I told you a moment ago, these problems are given to you either as standard form, where they're giving you totals, or you have translations where they're talking operations in here. Which one is this? It is one of those. Well, just ask yourself a simple question. Do you got any totals? If you have totals, then you have standard forms. So who are the totals? Yepers, that's one of them. Yep, that's the other one. 103, not 107. You have standard form, meaning both of our variables are going to be on the same side. Okay? All right, so we've used those. I'm going to work with the bottom equation because, again, it's going to make more sense to work with the bottom one, and then you'll see what falls out for the top one. What does this equation down here look like? Yes. S. Why'd you pick S? 6%, right? S, 6, okay. 0.11 or 0.11. E for 11. Good. Oops, my little sign popped up there. I'm going to go ahead and put the 0.11 up in there. Make it kind of match what I did before. There we go. That's the last equation. Because if you look at these numbers, the 0.06 was about the percentage, about interest. And remember, when you put percentages into a problem, you have to put them as their decimal. That's why it's 0.06, because that's what 6% is as a decimal. And then over here, the 0.11, that was 11% as a decimal. And again, these numbers were about interest. And interest, what was the 103.79 about? Interest. Interest, interest, interest. All those numbers are about interest. Uh-oh. What do you notice? I've used all the numbers. What's the other guy going to look like then? S plus E. Which again makes sense because what is the S and the E about? The money you're putting in at that. I'm putting so much money in at 6%. I'm putting so much money in at 11%. That better be the total amount of money right over there, the 1,324. This is all about money, money, money. Interest, interest, interest. The equations make sense with what you have in them. Now all we got to do is solve. Any method you want. What do you think would be the easiest? There you go. This is a lot like the last problem. All I did was change it from a play to money and interest. So we can do elimination. That's what I would do. I know a lot of students would like to do substitution on this. Again, don't get me wrong. It's pretty easy to do substitution. You can get the S by itself. You can get the E by itself and plug it into the other guy. It all works. But remember, I just gave you kind of a secret the other time. If I want to get rid of E, all I got to do is turn this into a negative 0.11. If I want to get rid of the S, all I got to do is turn that into a negative 0.06. So elimination is pretty easy. Who did you say to get rid of? The E, was it? All right. No, whatever you suggest. So we're going to multiply everybody by a negative 0.11. So what is negative 0.11 times S? Negative 0.11 S. We already know that that's going to be negative 0.11 E. And then what is negative 0.11 times 1,324? Negative 145.64. Anybody want to argue on that one? Double check, or does it feel all right? I'm going to trust your math. All right. Now the bottom guy was a positive 0.11. So do I have to do anything to that bottom equation up there? Nope. So we just write it down. 0.06S equal to 103.79. Okay. And what do we do now? Add down. So what's negative 0.11s plus 0.06? Negative 0.05 s. We know the e's are gone. What is negative 145.64 plus 103.79? And what do we do now to figure out what s is? There you go. Divide by negative 0.05. Divide by negative 0.05. S is equal to $837. So at 6%, we put $837. How do I figure out 11%? Yeah, right? Who would be the easiest one to plug into? The top one, just like last time. Yeah. So we got $837, right? Plus E equals 1,324. 1,324, right? Okay, and that's my E. So how do we solve this? Minus 837 minus 837. E equals 487. Yeah. I trust you. Dollars. And there you go. So just make sure that you fill in the correct blanks or select the right answer. S, 6%, is $837. And the 11% is $487. That's me. I'm always going to write my labels out. But in the problem, you should make sure that you just read it carefully. Usually, most of the time, they have the symbol. And so I think it'd be all right. But might be something you might want to ask your professor just to double check. I think it just wants the number. Most of the time, you don't have to put the label in. All right. Halfway done. But we're almost out of systems, I promise you. Just a couple more. Again, they want us to graph. So this is where our graphing calculator is going to help us out a lot. Our graphing calculator is going to help us out a lot. I do know on this test, you know, I've showed you those 5 options that we had before. But on this one, they're going to give you some brand new options. Actually, 2 options. One of them will look like this. And then it has some shading on that side. One of them will look like that and have some shading. Okay? So I'll explain how this is going to work once we start going through the graph process. Okay? All right, so up here, in order to graph this, what do we have to do first? Because this is no bueno right now. You got to get the y by itself. In order to use our calculator, we have to get that y value by itself. How do I start to get y by itself? Yes. How do I move a positive 1/2 x? Minus. Minus 1/2 x. Minus 1/2 x. So negative y greater than, what do I have on that side? What do I have on the right side? Or you could have 3 minus 1/2 x. It's all the same. But we're not done yet. What are we going to do now? Not minus a negative 1. You got to divide by a negative 1. Because I want y on this side. I don't want a negative y. So that means you got to divide everybody by a negative 1. So y. What happens to the negative 1/2 x? Oh, good. I was going to come back to that, but that's fine. Yeah, remember, when we divide by a negative 1 with inequalities, this guy right here changes directions. So it's now a less than symbol. So what is negative 1/2 divided by negative 1? A positive, that's right, because all you're doing is changing the signs when you divide by a negative 1. So we got a positive 1/2 x. What's a positive 3 divided by a negative 1? And now we're ready to rock and roll. Now we're ready to rock and roll. Okay? So now we can start talking about this information that's over there. So notice one of the big differences between these two things is one is solid, one is dotted. That's based off of the symbol. Since we just have less than, which symbol should we be using? The dotted or the solid? The dotted. So when we go to graph, make sure that you choose this box to graph. Okay? And so let's go ahead and start graphing. This is just like graphing that we did before, right? Basically, I think it was the second problem we had. So how do I start to graph this? What are we going to do first? That's right, plot B. Plot B, which you told me B is a negative 3. So I'm going to go up to my graph. I'm going to put a dot at negative 3. Right there. That's Google Maps finding us. And now what are we going to do? Yeah, that's right. Go over which direction to? Correct. Use M. And so M was the 1/2. So that means go up 1 and to the right 2. So from 3, I'm going to go up 1, right 2. So up 1, right 2. Up 1, right 2. Up 1, right 2. I'm just doing this so I can do some other points and make my line a little bit straighter. Okay? And of course, this line should be what? Dotted. Okay? And when you select this tool right here, and you graph it just like before, when you make your first plot on the y-axis, and then you do your slope and make the second dot, you will see that dotted line pop up when you choose this box. So this box, it actually takes 3 clicks to complete. 2 of them to make your line. So this was the first click, second click. That solidifies the line. The third click is to tell us where the shading should happen. So when you hover your mouse over here, you'll see this side get shaded in. Or when you hover your mouse over here, you'll see that side get shaded in. You have to make a third click anywhere in one of those regions to where the shading should be at. Now, this is where your calculator will come in handy for you. Okay? So we jump into our calculator, and our calculator can graph that for us. So if you go into the y equals, what was our equation again? 1/2 x plus negative 3 or minus 3. So to put the 1/2 in, that's our fraction. Alpha y equals, and you can put in that fraction of 1 over 2. Scroll out to the side, put your x in, and then it was minus 3, right? Or if you put plus a negative 3, all the same. Now, for you to see the shading, for you to see where to shade, I need you to scroll all the way over here to the left and highlight the color and the line. See how there's that box around the color and the line? Okay? You're going to hit enter. And you're going to scroll down to the line piece. And in here, you're going to have a choice between 2 symbols that I want you to look for. I want you to look for either the upper half triangle. So this triangle is kind of shaded on the upside. Or look for the lower half triangle, because it's shaded on the bottom side. How do you know which one to pick? Again, that is based off of your symbol. When you are the less thans, you will pick the lower half triangle. If that was the greater than, you would pick the upper half triangle. Okay? So since we are the less than, that's the guy that we want to look for. The lower half triangle. So I go back to my calculator. Oh, look, we're on the lower half. Scroll down, hit enter. And notice it's now changed. And now if I graph, it will show me where the shading should be, and that's how I'm going to know where to make my third click. So hit graph. Now I know where to click. Sure. Mm-hmm. When it's facing to the right, that's greater than, because it's pointing to the big numbers, if you can think about it like that. All the numbers that are to the right are big and positive. When it's pointing to the left, like it's doing right here, it's pointing towards all the smaller numbers. Less than. All the negative numbers. Uh-huh. So that's a less than. Okay? And again, like I said, this is 3 clicks, so now you know where to do the third click. So over here, you would click somewhere down here in that region, and it would shade in your picture. So these buttons take 3 clicks. Make sure you choose the correct button to begin with, though, whether it was dotted or solid. Okie dokie artichoke. So there's question number 11. So again, remember that these buttons take 3 clicks. 2 clicks to make the line, and then the third click is where the shading happened. So if you look at your graph, the shading was down below our line. So that would be where I would click the third time to solidify the shading. Okay? All right, next question. I think this is finally our last system. Let me double check. Yes. So question number 12, we're done with systems after this guy. And so all you're going to do is repeat the process again. Take what we just talked about, and then now you're going to do it with 2 of them. Okay? And again, they're going to give you those same pictures down below, I believe, that are the dotted with the shading or the solid with the shading, and you got to pick the correct one. Cool thing is, both of these equations are in what form? Solid. Solid? Oh, you're okay. Yeah, both of these are going to actually use the solid box. But what form are these equations? Standard, slope-intercept, point slope? Slope-intercept. So that makes that we don't have to do any rearranging like what we did on this problem. They're ready to go. So, up here, what is your m in this equation? Negative what? Positive 3. 3 over what? 1. What's the 3 tell us to do? I'll get to that. I'm going to plot that too. I promise you I'm not going to go out of order. Yeah. So what does the 3 tell us to do? Rise 3. What does the 1 tell us to do? To the right 1. Careful when you say over. I will always ask, well, which direction over? Right or left? And then what was your b? Negative 2. All right. So now how do we graph? Plot the b first. I was just writing down my information so I don't have to go back to it. So we're going to plot the negative 2. So that's like my first click. And then what are we going to do? Rise 3. And then what? Over to the right 1. And then that's my second click, and that will solidify the solid line. And then you'll have one more click to do, which is where the shading occurs. I'm just going to put on another point for this so that way I can kind of make a better looking graph. So again, where am I going to go figure out the shading at? Calculator. So I've done my 2 clicks. Remember, this guy was my first click. This was the second click. Now I need to figure out where I need to click the third time. So I'm just going to let the calculator do that. I'm going to put this equation in, and it's a less than symbol. So do I want the bottom triangle or the top triangle? The bottom, because it's a less than symbol. So I believe we're already set for that. Yep, I've got the bottom triangle. All I just got to do is change this out for my new equation. So hit clear. What was my new equation? 3x. That's what I thought. 3x minus 2. Hit graph. Now I know where to make my third click at. Yes. The bottom triangle and the top triangle? Yeah, that's about your symbol that's right here. When you have less than or equal to, look for the triangle that is shaded on the bottom. So where that is located is if you scroll all the way over to the left. I highlighted this last time, and I hit enter. Down here at the line, you scroll left and right, and you see all sorts of different symbols. I need the one that looks like that. If it was the greater than, I'm looking for that symbol. Okay? But it's the less than symbol, so that's the one I want. Correct. So we hit graph again, like I said, and now we know where to make that third click. So on my graph over here, I would click in this region, and it would shade this region for me. Follow? And now repeat for the second equation again. So again, what's our m? Negative 5 over 2. What's that top value tell us to do? Say it again. Down 5. And then what? To the right 2. You could do up 5 and then to the left 2, because that meant that you just put the negative with the bottom. Yeah, you could put the negative either way. You could put it with the top, you can put it with the bottom. I normally just throw it in the top. But that's me. You do you, boo. All right, and then what was our b in this case? Negative 3. So we're going to plot negative 3. And then what are we going to do from there? So that's my first click. 5 down. Oh, man, my graph isn't really big enough. So maybe that was a good idea for what he gave us. Let's go up 5 and to the left 2. So we'll reverse the directions. So 1, 2, 3, 4, 5, and then there we go. That's a little bit better. And oh, was this line solid or dotted? So again, we're picking the same box. So this is our first click down here at negative 3. Then we counted up 5 to the right or to the left 2. There's the second click. So our line comes in, solidifying itself as best as possible. That's a horrible line, my bad. And then now we got to figure out where to click for the shading, right? Okay, so we just go back to our calculator. This time it's a greater than symbol, so what kind of triangle do I want? We want the top triangle, so we're looking for that one. And then we're going to put it in our equation as well too. So I'm going to scroll over. I mean, if you want, you can also go down to y2, and so you can see both of these at the same time, because that's really what they want. But I'm going to scroll over to the left here, all the way over. I'm going to go ahead and find my triangle. Remember, we want the top one. There it is. So I just had to scroll to the right one. And then now let's put in our equation. How do I put in a fraction? Alpha y equals. So we've got negative 5 over 2. Scroll out to the side, put in our x, and then it was minus 3, right? Minus 3. Graph. And there's what it looks like. And so it looks like I will put a point to the right of my line. So I'll come over here, and I'll click anywhere over in this region. And what you'll see is you'll see your calculator shade all this good stuff that's right over here for on that side of the purple. Okay. Mm-hmm. Yep, that red line that you see on your calculator, that is my purple line that I have up here. And what they're looking for in this, because they might have you do one other thing, they might have you put a final dot in the solution area. So if you're looking at your calculator, the solution area is where there is both red and blue. So if you notice, when you graph, it kind of creates 4 regions. It creates a top region, a bottom region, a right region, and a left region. Which region is the solution? The top, bottom, right, or left? Where is it that I have both red and blue? Is it the top? Is that red and blue? The bottom, that one's red and blue. Is this guy red and blue? No, that's just blue. Is this red and blue? Nope. Is this red and blue? That's the answer. So they might have you put a dot in there, or it might say you would be on the left region. Because this is the top, or sorry, right region. This is the top, this is the bottom, this is the left, this is the right. You did something like that in your homework. They asked you that same kind of question. Correct. So if I'm looking at my graph over here, I want the region that I have both purple and green, my Hulk colors. And that region is right here. So if I had to put a dot, I'd put a dot in here, representing, hey, that's my answer region. Or, again, like I said, they might have a drop down. How? Ask. It's okay. That's the solution. So the solution is any point that is in here. You can't. You can't write that in numbers. That's why it might be a drop down saying, where's the region? Is it on top? Is it on bottom? Is it to the right or to the left? Are regions to the right? Or, like I said, they might have you put a dot there. When you put the dot in this region, you're saying, this is the region where all the answers are at. Anywhere in that region. Oh, I wasn't even looking where I was putting it. I was just putting a dot in the region. Okay? Any questions? There we go. Now we're done with systems. Whew. Now let's move on to some long division. Let's move on to some factoring. Okay? All right, long division. I think you only have one of these guys. Yeah, everything else from here on out is factoring. So long division. We're even nice to you a little bit on this one because if you notice, everything is in standard form. There's no one missing because it goes 3, 2, 1, none. Remember that when you are doing long division, you need to make sure that you are in standard form and that none of the terms are missing. If we were missing a term up here, we would have to put a 0 in its place to keep track of it. Okay? So long division is just like regular division. Which one of those pieces goes under the division symbol? The top. So 25x cubed plus 10x squared. I didn't make my division symbol long enough. Plus 17x minus 13. And then that means the denominator has to go out front. All right. There are 3 steps to division. 3 steps. And when we're doing polynomial division, it's all about getting rid of your terms as you move along. So we want to get rid of 25x cubed. This is what we're going to base all that information on. So we need to ask ourselves this first question. What times negative 5x will give me 25x cubed? You got it. Because negative 5 times negative 5 is the positive 25. And x squared times x is x cubed. So there's our top piece. Negative 5 x squared. And remember with regular division, what you do is you take your top piece and you multiply it by what's in front. And we're going to do that. Negative 5x squared. And we're going to multiply that by negative 5x plus 1. Okay? And no surprise that our first term, oops, go back. I can't see what I'm doing. There we go. And it's no surprise when I distribute through that my first piece, hold on one second. I need to grab something, but I need this to stop moving on me. Now I can grab it. It is no surprise that our first piece here is 25x cubed. That's going to happen because we want to get rid of that first guy. But what is negative 5x squared times the 1? Negative 5x squared, right? And what do we do in long division now? We subtract down. Again, no surprise that the 25x cubed cancels out because we engineered it to do that. But what you will see me do over here, and this is where we get in trouble as students, is you will see me write out this information, the subtraction step that you actually have to perform. So what you're really doing is you're taking 10x squared minus a negative 5x squared. That's really what's going on. We're taking 10x squared minus a negative 5x squared. What happens with two negatives by each other? So what is it that we're really getting there? 10 plus 5? 15x squared. Some of your professors might have already had you change the signs on those, knowing that when you subtract down, everybody becomes its opposite down here. So some of you might have 10 plus 5x squared there, which is all the same. Okay? And then what happens with the rest of the terms? They trickle on down. Any questions about that first piece? All we're going to do now is just keep repeating that over and over and over again. We just got a new term that we want to get rid of now. Who's the new guy that we want to get rid of? The 15x squared. But before we do that, any questions on this piece? So why do I not put anything up top because of this multiplying? Because we don't care about that guy. He's only used to help us down here when we subtract down. Yes. Okay. No worries. I know my green kind of blended in right here and all that junk and things like that. Okay. Do you know where the negative 5x squared came from? Okay. Do you know where this part came from? We distribute through. What's negative 5x squared times negative 5x? 25x. Because what do we do in long division? We subtract down. That's why that's there. Because we're going to subtract down. Okay? Does that help? All right. Kind of. It's all right. So let's do it again. We're going to repeat. And who are we getting rid of again this time? That's the new guy we want to get rid of. So, again, we ask ourselves, what times negative 5x will give us 15x squared? Negative 3x, right? Because negative 3 times the negative 5 is a positive 15. And x times x is x squared. So we're going to put negative 3x up top. Yes? Whoa. Signs do matter. I didn't take 10 minus 5. I took 10 minus a negative 5. That's why you saw me write this down, because that's really what's going on there. You are subtracting down. This was my top guy minus my bottom one. 10x squared minus my bottom guy. So signs matter. Because what's a minus and a negative do together? Become plus. Because 25 minus 25 is 0. Yep. Yeah, it's the subtraction part that gets everybody. It's the part that I see the most trouble with. That's where we have our little downfall. All right, so we already know what our value is up there, the negative 3x squared. or sorry, just the negative 3x. So we're going to multiply that by negative 5x plus 1, right? We're going to take our blue value that we had up here, and we're going to multiply the entire beginning piece. Negative 5x plus 1. So what's negative 3x times negative 5x? Which is no surprise to us. We knew that these two were going to match. And then what's negative 3x times the 1? Any questions so far about where that came from? We took our value right here that we just found, and we distributed through. And now what do? Subtract down. What's going to happen to the x squareds? Gone, which we knew would happen. And I'm going to write out what we have over here. We have 17x, it's my top guy, minus negative 3x. You follow me on that? What happens with two minuses by each other? So what do we really get here when we subtract down? What happens with this? Brings it down. Any questions about that step? Again, it's the same steps. Just the only thing that was new was who we were trying to get rid of. Who are we trying to get rid of this time? 20x. Repeat the same process. We're going to repeat the same process. Nothing changes. It is these three steps all the time. Figure out how to get rid of your first term, do some distributing, and then you got to subtract down. Over and over and over again. So again, we're going to ask ourselves this question. What times negative 5x will give us 20x? A negative 4. So we're going to come up here and write that out. Negative 4. And now we're going to take this negative 4 and we're going to distribute it through. Oh, my green box is gone. Come back. Negative 4 times negative 5x plus 1. What's negative 4 times negative 5x? Which we knew was going to happen. It's not a surprise. What's negative 4 times 1? Negative 4. What do we do now? Subtract down. What's going to happen to the x's? Gone. But then over here, I'm going to write out what I've got. Negative 9. So, because that's negative 13 minus a negative 4, right? No. She was correct. It is a negative 9. Negative 13 plus the 4. And that gives us the negative 9. And you can't do anything else now because there's no way I can get a negative 5x into a negative 9. That's our remainder. So up here in the box, now we're ready to answer some things. What's the quotient? What's the remainder? There you go. Sure. You can write anything you want down. And there's your one and only one long division problem. Yeah. No, you're fine. Where all do I need it? Like just right there? Or, okay. Everyone good? No worries. Not sticking with you, huh? I take it I need to scroll down just a little bit more for you, right? Okay, no worries. And then the rest of this is all factoring. Factoring after factoring after factoring after factoring. Which hopefully this part of the test will be just a little bit faster than the beginning part of the test. All good? Let's hit up factoring. Cool thing in this section when we're getting to factoring now is everything, as far as these questions come at you, they come at you in the order that you were taught. So one of these questions is about a GCF. One of these questions is about grouping. Then you will hit up trinomials, and I believe there are 2 of those. And then you will hit up a difference of squares, and then you have cubics. Okay, so it's all in the order that you should have been taught in class. So since this is the first question, what was the first thing you learned about factoring? The greatest common factor. Okay, so the GCF. So GCFs, when I talk about them, there are 2 kinds of GCFs. There are numbers and there are variables. And I have my students ask themselves 2 questions. The first one deals with the number. Is there a number that can divide all of these? 58, 22, 34. 2. Since you said yes and you identified the number, that means you have a number GCF. So we pull that out. So we're going to pull a 2 out. Okay? The second question you ask yourself is, do all the terms have a variable in common? Yes. Who do they have? X. Okay, they have an X, and now you have to say, okay, how many of those can I take out? And I can only take out as many as what everybody can cover. Or in other words, look for the smallest power. What's the smallest power? 5. So that's how many X's I can pull out of everybody without being in trouble. So now all you got to do is tell me what's left. Remember, this 2 divided everybody, right? So what's 58 divided by 2? There were 15 X's, but I pulled 5 out. X to the 10th. Good. So what's 22 divided by 2? Okay. There were 11 X's, but I pulled 5 out. X to the 6th. Yeah. Okay. What's 34 divided by 2? Okay. There were 5 X's, but I pulled 5 out. So no more X's. And that's it. You're done now. It's just a simple GCF problem. That's all they want you to do. Okay? Make sense? Okay. The next problem. After GCFs, you learned how to group. Because those of you that learned the AC method, that was what you had to do to finish out the AC method. Okay? So, grouping is a 4-step process, and all grouping is a giant GCF problem. That's all grouping is. It's a giant GCF. So, first things first. In grouping, what do? Not yet. Well, yeah, we should look for that, but there isn't a GCF in this problem. It's pure just do some grouping for us. Yes, there we go. The reason why we call this grouping is because we're going to group. Group the first 2. Group the last 2. So that's the very first thing you got to do in grouping. And now all you're going to do is GCFs. So you're going to look at this first parenthesis. What's coming out? The Y. Because both of them have a Y value. Or Y variable in common. So we pull out the Y. Tell me what's left. X plus 2. Perfect. And in my course, I teach my students that whatever this first parenthesis is, the next one has to match it 100%. So you can actually think about a GCF for this, or since this is my first parenthesis, my next one has to match it. Has to. So I can think about it as a GCF, or I can think to myself, what times x goes back to a -8? A -8. That's what should be in front of that parenthesis. And if you verify this, what's -8 times 2? -16. See, look, you went right back to what you had. So you can think about it as a GCF, or you can write these two parentheses that repeat and think to yourself, what times x brings me right back to what I had a moment ago. Yes, these two parentheses have to match. If they don't, then you don't need to be doing grouping. So, last but not least, we create our two parentheses. Because now you have everything. One of your parentheses goes the repeat. The other parenthesis goes your two GCFs. So, what do you want to put in the first parenthesis? The repeat. So that's x plus 2. So who are my GCFs? Y minus 8. The numbers in front of the parenthesis take over the second one. And again, you could switch this around. You could have y minus 8 and then the x plus 2. That's grouping. See, these are so much faster. And now the next two problems you're going to get into are all factoring problems. Yes. Last answer. Left it as this guy right here? Yes, because that's not completely factored. All these directions will say, well, usually it says completely factor. So this guy is not done yet. All right. Now you're factoring trinomials. That's what the next two problems are. Factor the trinomial. Factor the trinomial. I taught my students 3 ways to factor trinomials. There are technically 4 ways total. There's guess and check. I taught my students the AC method. I taught my students box method. I taught my students slide and divide. It's dealer's choice on this. You do whatever's comfortable. I think most of you learned probably the AC method. Does that sound familiar? We take an A times the C. Okay. But I put a slight little spin on it, so hopefully this will kind of match up with what you're doing. All right. So when I teach this to my class, the AC method, the first thing I ask them to tell me is, what are the A, B, and C's? Remember, quadratics, or in other words, trinomials for us, are written in this form. AX squared plus BX plus C. A is always in front of x squared, B is always in front of x, C is always by itself. So what number is in front of x squared? There's a 1 there. Write down 1. What number's in front of your, or what is your B? 5. And what is your C? And now I have my students play a game. So this is my little twist on it. I call it the X games. Okay? So this is where up here we're going to take A times C. This is just a way to kind of organize the information that you're about to do. And you do this in the AC method. I just organize it a different way. So up on the top is your A times C. So what is 1 times -14? -14. Down here is your B. It's 5. So the X games, what it's all about is you're finding me 2 numbers. And these 2 numbers must multiply to the top, but add to the bottom. They must multiply to this top value, but add to the bottom. So here's how you figure that out. Look at the factors of AC. I usually ignore the sign, but look at the factors of 14. What are the factors of 14? What times what gives me 14? So 2 times 7, and there's one other one. 1 and 14. Those are all the factors of 14. Now up here, how can I get a 5? 7 minus 2, right? So you have found the numbers now. 7 and a -2. Because 7 minus 2 is 5, right? Is 7 times a -2 a -14? See, works. You found the game. And now all you do is grouping. Because these two numbers replace the middle. So all you're doing is grouping now. X squared plus 7x minus 2x and then minus 14. These two numbers right here were the middle. Because if I take 7 minus 2, I get the 5x back. Follow me on that? All this is grouping. Yes. Yes? I can show boxes here in just a second. Boxes all work the same. I begin out with the boxes the same way as this guy. Sure. No worries. Some people, yeah, the boxes are simple. I don't know a lot of the students that I teach up here, when I show the box, they don't like it. They like this better. But it's fine. I'll show the box. So again, we're just grouping. So what's coming out of the first parenthesis? X. What's left? And what did I just tell you about grouping? That has to be the same over here. So what times x will give me a negative 2x? Negative 2. And what are the two parentheses now? So she's putting the GCFs first. X plus 7. There you go. Oh, no. This is just one of the methods I taught. This is the method that the book uses. Although the book does not show the X games, that's just my little spin on how to organize the information that you're working with. I make it a game for my students. Yeah. Oh, yeah. That's what we call guess and check. Most of us are pretty good at guess and check. That's how I learned. I didn't have all these fancy methods. But when you get to the next one, it's a little bit harder to look at it and know what that information is. That's why I revert to the AC method. Yeah, when your A is 1 like this, the AC method, all the methods are a little bit easier because usually you can look at it and know what's going on. But when your A is not 1, that's when you want to revert to one of these methods. So you want to see the box method. So in the box method, I'm going to take everything that I did right here, and each one of those terms goes into a box down below. So my beginning term, which was x squared, always goes in the top left. My beginning term always goes in the top left. My end term, my C value, always goes in the bottom right. The two diagonal squares there, those are the numbers that we found in the X games. And it doesn't matter which one goes where. I can put the negative 2x right here. I can put the positive 7x there. I can put the positive 7x down here. I can put the negative 2x right there. Doesn't matter. Which one would you like where? So that would be actually a positive 7. And then the negative 2 is going to go up there. Again, first term at the beginning. This is the ax squared. This is the c. These terms are the ones from the game. And all you do now is GCFs. What do these two boxes have in common? What do these two boxes have in common? 2, and since they're both negative, pull that out. What do these two boxes have in common? What do these two boxes have in common? A positive 7. Because we only pull out a negative if they're both negative. And those are the two parentheses we had a moment ago. There you go. All right. So then we got this guy. Again, A is not 1, so that's where it helps to know, like one of these methods, like the box method or the AC method. You should be asking yourself, though, in this one, is there a GCF? We might sneak one in there where you have to pull that GCF out before you do anything because it might not factor. No, and there's not. So again, this is where you're going to rely on your method. And I'm going to do the AC method because, again, that's what our book runs through. So A is equal to 6, B is equal to 37, your C is equal to 55. Okay? So we're going to play that X games. Up on top goes your A times your C. So I need to know, what is 6 times 55? 330. Lovely number. Down below goes our B. All right. So we need to find two numbers that will multiply to 330 but add to 37. So let's start getting some factors of 330. All right. If you stink at finding factors, let me show you something that you can do on your calculator. Go up here to your calculator, go to the y equals part, and let's just go ahead. I got to clear out my stuff from before. And I'm going to turn my little picture right here, the triangle, back into the normal line. So if I scroll down, whoops. If I scroll down and go back to, there's my normal line. And the same thing for this guy. Nice little trick to help you find factors, if you stink at finding factors. So go up here, and we need factors of 330, right? So take 330 divided by x. Don't hit graph, but what you want to do is you want to go look at the table of this, and the table will show you the factors. So hit second graph, and that brings up a table. And now you can start to see factors. Anybody that is a decimal, you need to ignore. Anybody that is a decimal, you need to ignore. So we can see that 1 and 330 is a factor because it's not a decimal. We can see that 2 and 165 is not is a factor. Okay? So let's just kind of like start writing these down since you've got them. We've got 1 and 330, right? 2 and what? 167, 3 and 110. What else? 5 and 66. What else? 6 and 55. 10 and 33. 11 and 30. You can see how these numbers are getting larger. The other side starts honing in on it. What else? 15, 22. Anybody else? All right, but we already got that one, so we're done. So up here, I need two numbers. We already know they multiply to the top, but is there a way that I can add two of these numbers to 37? The 15 and the 22 at the bottom, because 15 plus 22 is 37, right? And 15 times 22 is the 330. So we found our numbers. It has to be 15 and 22, because these two multiply to that, and these two add to that. And now all you do is grouping. Now all you do is grouping. So we've got 6x squared to begin with. 6x squared. Take one of our numbers, and it doesn't matter which one. Do you want the 15 first or the 22 first? Okay, 22. And then you're going to put the 15. And then you're going to put the final number, which was 55. Okay? And we do grouping. So we group the first two. We group the last two. So what GCF is going to come out of the first parenthesis? 2x. Okay? And that leaves me with what? And we know that that parenthesis has to repeat. 3x plus 11. So what times 3x will give me 15? A positive 5. And I'm going to put the plus sign in front of it because that's important for us. Any questions so far? And then now write your two parentheses. What are they? So she put the repeat first. And then there's your GCF. Perfect. There it is. Nope, you could put the 2x plus 5 and then the 3x plus 11. Nope. Yes. The box. So again, it'll be these same values. Okay? In the top corner right here goes 6x squared. The bottom right is the 55. And these two boxes go whichever number you wanted from the 15 to the 22. So which one do you want in the bottom left? Remember, that was from playing the game. Okay? And then that means the 22 goes here with the x. So what is in common in this first box? What do they both have? 3x. What is in common in this second box? Nope. 11. Positive. That was one of our parentheses. What's in common in these two? And an x. Both of them have x. What's in common in these two? And that is a positive 5. And that was the other parenthesis. Answer. Yes, they have to add to that middle piece. That's the key. Yep. All right. I believe we have 3 more, and these are a little bit shorter than those, I promise you. So this one is what we call the difference of squares. Remember in class, I'm sure your professor showed you how this works, that if you have a squared minus b squared, these things will factor out to an a minus b and an a plus b. Or, again, remember you can reverse those around. Okay? The key to this, you can do the AC method on this. You can do the box method on this. You absolutely can do those 2 methods on this. The piece that you're missing in here is the b, right? So what number represents b then? If it's missing 0, you can run the AC method on this. Because that's the first term, that's the last term. Your b term would be 0. No. But if you wanted to do AC or box, yeah, just remember that the b is 0. Yeah. I'm just showing you that it really is a trinomial in disguise. But I show a different way. I call it the square root method because we call this a difference of squares for a reason, because they are squares. We can take square roots of these. And so what we're going to do is we're going to take the square roots and we're going to figure out what is the real a, what is the real b. What was it that was used to create this? So we're going to take the square root of 49, not 94. 49y squared. What's the square root of 49? 7. And the square root cancels out the square, so it becomes 7y. That is your a. Yes. Yeah, we're going to get there. Yeah. And then the next piece, what's the square root of 25? That is the b. All you have to do is fill in the a, b's over there in the parentheses. So what does my first parenthesis here look like? No. The b as in this guy. Yeah. This is different. This is not the AC method. I said if you want to do that, that's fine. That's a little bit more work, but do not get me wrong, you can. This is so much faster though. So what would that first parenthesis look like with the minus then? 7 what? 7y minus 5. Yeah, there we go. 7y minus 5. Then all you're going to do, what would the second parenthesis look like? 7y plus 5. There you go, done. That'd be it. It's called the square root method of factoring. Square root the first term, that tells you a. Square root the second term, that tells you the b. Okay? And this only works on a difference of squares. That little square root method. Nope, because the next one, they're cubes, right? But there is something similar to this that we're going to do. So in, oh, okay, no worries, no worries. Going back. Whatever you need. Okay. So the next guy. So we want to factor these. The next two are all about cubics. This was section 3.6. So remember, there are two ways that we have cubics. We have what is called a sum of cubes and a difference of cubes. Who do we have here? Is this a sum or a difference? This is a difference. How'd you know it was a difference? Because it has a what? No. Why is this a difference? Say it again. The minus right there. So this means that we have a difference of cubes because it is a minus. And then you have to remember what a difference of cubes looks like because it's very formula based. A difference of cubes looks like this. You got a cubed minus b cubed, which is a lot like, kind of like what you saw last time, but instead of being squares, they're cubes. And it factors just like this. A minus b, and then it's a squared plus ab plus b squared. That's how it will factor every time. And you need to know that. You need to know that. So just like last time, we're going to figure out what a and b are. But instead of doing square roots, we will do what kind of roots? Cube roots, since we are talking about cubes. So if I want to figure out what a is, I'm going to cube root the first term. So what is the cube root of 27? In other words, what times what times what? The same number over and over and over will give me 27. 3. So 3, and then what's the cube root of x cubed? Just x. That is our a. Just like last time, but instead of taking square roots, we did cube roots. And then when I want to know b, I'll take the cube root of 125. What number times itself 3 times will give you 125? 5. Now you know b. All we're going to do, fill in that equation over there, just like what we did last time. So this first one is supposed to be a minus b. So what am I going to put in there? 3x minus 5, because our a is 3x and our b is 5. And now we'll take this piece a little bit slower. So the next piece says, tell me what is a squared. So I need to take my a over here and square it. So what do I get when I take 3x and square it? What do I get when I take 3x and square it? Or in other words, what's 3x times 3x? 9x squared. Because 3x times 3x is 9x squared. And now they want us to take the a and b and just multiply them. So what's 3x times 5? 15x. And then last but not least, they want us to square the b. So what's going to happen when I take 5 and square it? Plus 25. And that's it. Once you know what a and b are, you're just plugging into that formula that's right over there. And it factors like that every time. And once you get it factored like that, you're done. There's no more to do. All right, so here it says square the a. So we got to square this 3x. So what's 3x times 3x? 9x squared. The 15x comes from taking the a and the b and multiplying them. So if I take 3x and times it by 5, I get 15x. And then the 25 comes from squaring the 5. 5 times 5 is 25. following my formula. Okay? Everyone good? No worries. And then we're on our last problem. And we're done. Yay! That's what chess is going to be like. Everyone good? All right, last problem. So again, like I said, we have a difference of cubes, and then the other one we have is a sum of cubes. That's what this guy is. And again, it has its own formula, and it's very, very similar to a difference of cubes, just the only difference is where we're going to put the plus and the minus sign. So a sum of cubes looks like this, a cubed plus b cubed, and it factors out like this. A plus b, in parentheses, then it's a squared minus ab plus b squared. So the difference between these two is all about where you put the plus and the minus sign. In the sum of cubes, it's the plus in the first parenthesis, and then it will go to a minus in the second. In the difference of cubes, you'll switch those two signs around. That's the only difference between these two. It's the only difference is where you put the plus and the minus sign that you see over there. These work the exact same way. We're going to take cube roots to figure out what A is. We're going to take cube roots to figure out what B is. And then fill in. I did use the correct variables, right? Yeah, they were X's. Always make sure that you check and make sure that you use the correct variables. So in this one, we're going to be using Z's instead of X's. Make sure you use the right variable. So we're going to take the cube root of Z cubed. What is that? Z. So that is our A. Then we're going to take the cube root of 8. And what is that? That is our B. All you have to do is fill in the parentheses. So our first parenthesis is what plus what? Z plus 2. Our second parenthesis, filling it in. Z squared minus 2Z plus 4. Done. That is your exam 2. All that's going to happen is we're going to change the signs. Or sorry, not change the signs. Excuse me. Change the numbers. That's it. Questions? Thanks for joining me.